Hello everyone, this is week 4, day 22 of our Leetcode activity. Today's question is implement queue using stacks. So implement a first in first out queue using only two stacks. The implemented queue should support all the functions of a normal queue, which are first is void push. That is, it will take an integer x and push it to the back of the queue. Int pop. So this will just pop the front element of the queue and return it. Int peak, it will just return the element at the front of the queue. And boolean void, that is, it will return true if the queue is empty and false if the queue is not empty. So there are some notes we must follow. You must only use standard operations of stack. That is, only we can push to the top, we can pick or pop the top, we can check the size of the stack, and is also we can use is empty operation. That is, we can check if the stack is empty or not, and depending on our language. So this line has no relevance for us because we will solve this in C++, and it has a native library which supports stack. So let us see first of all, so what is a stack? A stack is we push elements. So we push elements and we have control, or we can access just the last element. That is LIFO, last in first out. That is, three can be accessed, three can be popped, and once three is popped, then we can access two. But what is a queue? Queue is queue is FIFO. That is first in first out. That is, we can access pop the first element, and after we have popped the first element, then we can go to the next element. So actually we know should not say pop here, we should say dq. So nq is adding a value to the back of the queue, dq is uh, removing the first value of the queue. So queue is, so the word queue is like, we can take it literally, that it is a queue to a ticket counter. The first person will take the ticket and leave first, and whoever is at the end, he will have the he will get to the counter at the last. After every element is processed, he will get to the counter last, and he will get his ticket and leave last. So whoever has joined the queue first will get out first. That is first in first out. So the challenge here is we have to use last in first out capabilities of stack and implement first in first out logic of the queue. So how can we do this? We can do this using two stacks. So we'll declare two stack. First, there are two stacks here. We'll call this stack in, and there is one more stack. We'll call this stack out. So this is our in stack, this is our out stack. So first of all, we need to design How many methods? Four. First is push, pop, peek, empty. So for push, we'll simply always push the element in. So let me take an example too, so that we can understand it neatly. Here, so okay. So here this first my queue and empty, these are just initializing the container. So that is not a problem. So first, so this is push one. So we will always and always push in the in stack. So we have pushed one, then we have to push two. Now see, here is the problem. Here the problem starts. What peak? So when we see peak, what our queue logic should return? It should return one. It should return one. Why? Because one was added first in the queue, and for the queue it can access peak pop the first value, or the value which was added earlier to every other element. So our logic should return this one, but as we are using stack, we can only access two, because this is our top element of the stack. So but we need to access one. So to solve this problem, we have introduced this second stack, which is out. So whenever someone calls peak, what we will do? First of all, we will check if our out is empty. If our out is empty, what we'll do? While n is not empty, out dot push in dot top in dot pop. So what here we are doing? This is simply performing. We will take the top element. What we will do? We'll take the top element. Wait a minute. We'll take the top element, push it to out, and pop this. Then again, we'll take this top element, push it to out, and pop it. And you can see the order has reversed. Here 2 was on the top, 1 was below it. Here 1 is on the top, 2 was below it, because we are pushing it from the back. Not from the back, but from the top. So here we have got the sequence which we needed, because now 1 is at the top of the stack, so we can access it, pop it, do whatever we want. And when we when the peak is called, we can just simply return the top element of out. Yes or no? We can just simply return top element of out. Now let us see that if I were to add more elements in here, 3, 4. Now someone called peak. What should I do? Should I again first first of all add it here, add the elements, like that is transfer the elements from in to out, pop them, and then return the top? No. First we'll check if this top is empty. If the top is not empty, that means there are elements which are not processed still, which are remaining to be processed, and those elements were added before any element in. Yes or no? So we will just simply return the top of out. that is you can see here, while not in dot empty. So this while loop will run till this is not empty, but this while loop is in a if statement. That if statement is out dot empty. That is, if out is empty, then and then only run this. That is, if out is empty, then only we will add the elements from in to out. But if out is not empty, we'll simply return the out dot top. That is the top element in this stack. So this is for peak. Now, what do we do for pop? Again, the same problem, that if this was the situation, when we say pop in stack, we can pop this. We can't pop this because stack does last in last out, last in first out. So four can be popped. We don't have access to one, but we need for Q logic. If we say pop, we need to pop Q first. So again, we'll do the same. What we will do for int pop? We'll first do peak. What does peak do? If out is empty, if out is empty, we will add all the elements from in. How we will add it? First we'll take the top. So we will always add the top and pop it from the in. So that is adding here, and all these are popped. So now again we have got what we needed. The first element is in the top, and we can simply pop this, and pop operation will be successful. Yes or no? That is what we are doing here. We do peak, but also there is this thing. So when we call peak, peak also checks that if out is empty or not. So if out was not empty, then again the same logic, that out already has elements which were added first and which are yet to be processed, yet to be popped. So we'll not add anything from in to out. Just we will simply int x is equal to out dot top, and top we will just pop the top and return x, because pop method should pop the first element and also return that element. So we will first store the element, pop it, and return it. So this was pop. And empty is fairly the most easiest of them all. That is, just we have to check if the in is empty and the out is empty. If both are empty, q is empty, and if any of them has at least one element, the queue is not empty. So as simple as that. So this is the logic, and this is the approach. How do we convert a last in first out logic to first in first out logic? That is, we will implement. That is how we implement queue using the stack. So this was the question. Thank you.